This video is for Chapter 8, Section 8.2 for the math activity Determining the Fairness of Games. We'll play and analyze games to decide whether they're fair or not. We'll need a 1 to 4 spinner for this game. Our first game is the racing game. Each player spins the 1 to 4 spinner twice and computes the product of the two numbers. If the product is 1, 2, 3, or 4, player A gets an X above that number, and you can see that's marked on the grid. In the same way, if this product is 6, 8, 9, 12, or 16, player B gets an X. So for example, if player A spins and gets 3 times 4, 12, B will actually get the mark. I've marked it here as X1 for the example I'll show you on the next slide. You can just mark an X. Then if player B spins and gets a 3, A would get the mark. If player A spins and gets a 4, A gets the mark. If player B spins and gets a 12, B gets the mark. And then you can also use linked virtual spinners here and just set up 2 4-sided spinners side by side. So here's my example. Here's my numbers. Remember, I have a 12, a 3, a 4, and a 12, and I would put X's above these numbers on my game grid. The game ends when one of the players has a column of X's all the way up to the finish line, and then each player gets 1 point for each X. So play the game to form an opinion about who has the advantage, if anyone does, player A or player B. And there's a game grid linked below this video. Based on playing this game, does it seem fair? That means, do both players seem to have an equal chance of winning? You might write a few sentences to describe your opinion there. Then in part B, we give you a multiplication table. We have the first spin 1 to 4 and the second spin 1 to 4. And you can see there are 16 spots. So for example, 4 times 3, 12, and then 3, and then 4, 12. So there's 2 ways to get a 12. So complete the table, which is also on the game grid page, to get the 16 products. And then using the table and assuming that each product is equally likely to occur, can you make a case that any one of the numbers is more likely to reach the finish line first, less likely to reach the finish line first? And then based on this table, is this a fair game? Are each player equally likely to win? And write an explanation to support your conclusion. Now, once you've thought about the racing game in question 1, we'll ask you to design your own. This game is similar, only instead of the 1 to 4 spinner twice, we'll use a 1 to 4 spinner and a 1 to 6 spinner. So instead of 16 products, we now have 4 times 6, 24. So design a game board and decide which products each player should get so that it's a fair game. So think of all the rules of the game. Each player gets a point for each X, and design it so that they're each equally likely to win, and then write a convincing argument to why your game is fair. You might like to use some grid paper for this, and 2 centimeter grid paper is also linked below the video. That's it for Math Activity 8.2. I hope you have fun thinking about games and the fairness of games.